Today is day 4 of Unit 2. We're going to take a look at deductive reasoning today. Follow this through, and some of this can be confusing. We just have to be able to think it through logically, which, like we've been saying all unit for some of us, is harder than others, but that's okay. We can work our way through this. So let's take a look. First, we're going to start with some vocab. We have the law of detachment, okay? The law of detachment. The definition of that is if the hypothesis of a true conditional is true, then the conclusion is true. It's very simple and straightforward. As far as symbols goes, if P then Q is true, and P is true, then Q is automatically true. And I'm going to show you how to draw this using a Venn diagram and label. That's an X right there. I'm going to show you how to draw and label it so you can see this as a picture and it'll make sense. So, let's take a look at the premise right here. Premise. If there is lightning, then it is not safe to be outside. So there I have lightning, and there I have not safe. I'm drawing the diagram so I can actually see what's going on. Okay, so I've drawn, using the first premise, I've drawn a Venn diagram with lightning and not safe. Then it says Maria sees lightning from the soccer field. Well, so then I'm going to put Maria in the lightning circle. Okay? Because she's in the lightning circle, she's automatically in the not safe circle. So the conclusion is it's not safe to be outside. Very straightforward stuff here with the law of detachment. That's usually the one that kids grasp onto easiest because it's very straightforward. If the hypothesis and the conclusion, if the conditional is true, and then I give you an example of the hypothesis being true, then the conclusion would be true for that example. So here's another one, law of contrapositive. If the conclusion of a true conditional is false, then the hypothesis is false. So if not Q, then not P is true, and Q is false, then P is false. And here we have the drawing, Venn diagram again, but the X is outside. So let's take a look here. If a student drives to school, boom, there's the student driving to school, then the student buys a parking permit. All right, so the student buys a parking permit. So we take the conditional and we draw our Venn diagram. Then, Jenny does not buy a parking permit. Boom, there's Jenny. If she doesn't buy the parking permit, then she's not inside that circle, which means that she's obviously not inside the smaller circle. So what's the conclusion? If she doesn't buy a parking permit, she also doesn't drive. I don't know why I have that. Pause. Sorry about that. Crisis averted. So, Jenny doesn't drive to school. If she doesn't buy a parking permit, she obviously doesn't drive to school because she's not in that circle. Unless she parks in the teacher lot and tries not to get caught, which you guys get caught and it annoys us, so stop it. One more, we have the law of syllogism. Now this one looks, the definition here is kind of long and looks complicated, but I'll explain it so that it's not. But it says that if two true conditionals exist, when the conclusion of one statement is the hypothesis of the other, then another conclusion exists. So here's how this works. If P then Q, and if Q then R, then P then R. So what that means is, and on this one, the only difference here is there's a slight difference. We have 3 circles now. So let's take a look. We have 2 conditionals to start. If it is July, then you're on summer vacation, okay? If you're on summer vacation, you work in a smoothie shop. So it's July, summer vacation. That's the first one. It's July, summer vacation. The second one was, if you're on summer vacation, then you work in a smoothie shop, okay? The conclusion here is easy to find when you see multiple conditionals, okay? If and if, for example, okay? Multiple conditionals. And if there's a part that repeats, what I'm able to do is if I eliminate the part that repeats, then I get the conclusion to the statement. So then you're on summer vacation, if you're on summer vacation. So the conclusion is what's left. If it is July, then you work in a smoothie shop. If it is July, then you work in a smoothie shop, okay? That's the law of syllogism. When we have multiple ifs, we're going to have 3 circles in our Venn diagram, and it makes it easier to do. Take a look at some practice. Go ahead and pause the video right here. I'll go over the answers after you unpause, and then you'll highlight anything you had questions on and ask me in class, or try again, see if you can figure it out. Okay, so pause the video now, please. All right, you've unpaused. Let's take a look at what we got. For the conclusion here, I got Robbie buys a parking permit. And which law was that? That was the law of detachment. That's the one that's if P then Q, P is true, Q is true. Number 2, the conclusion I got here was if a student drives to school, then the school assigns a spot. And because it was if, and if, that one's syllogism. All right, let's take a look at the next page. More practice. Pause the video again, practice these, and then unpause and we'll go over them. Pause it. Okay, so we're back. The conclusion here is Erica does not live in Florida. The law, contrapositive. And number 4, the conclusion here, 3 is a real number, and the law is detachment. More practice. Yay! Pause the video again. Try these two. All right, let's check our answers. I see all and all. I know that's not if and if, but this should have seemed like syllogism to you because of the part that repeats. High school athletes, high school athletes. That part repeats. That's a dead giveaway for syllogism. All varsity team captains have at least a C average. Same thing on number 6. Dead giveaway for syllogism because we had the repeating part. All rational numbers are complex numbers. If a hypothesis does not fit one of the 3 laws we have, then a conclusion cannot be drawn and it is invalid. So for example, if a figure is a square, then it is a rectangle. Quadrilateral ABCD is a rectangle. That doesn't fit any of our models. There's no conclusion here, and we can just write invalid reasoning. There is no reasoning. Invalid. Okay, it doesn't work. As far as the drawings go, the easiest way to draw that, let me show you something. Of our 3 types, okay, if you're drawing, let's add a page right here. So if you're drawing these out, we have small circle, big circle. The example they give you is in the small circle. That's law of detachment, okay? So that's 1. We have that one. We have small circle, big circle. The X is outside the big circle, okay? That is law of contrapositive. Okay, so there's another one. Then we also have if, or all, and that's when we have, yikes, law of syllogism. If you try to draw these out and it doesn't fit any of these models, then it's invalid. If it's not one of these 3, then it's not valid. So let's go back and look at this one. If we were to draw this one, figure is a square, so let me draw a square. Then, and I'll put an S for square, then it's a rectangle. Okay? The example they give is quadrilateral ABCD is a rectangle. Well, that would go here. Or it could go there. We don't know where to put it. Because we don't know where, it's invalid reasoning. So let's practice. Determine the type of reasoning, and then we'll go over them. Go ahead. I'll help you with the drawing. I'll help you set up the first part. So all plastic toys are unbreakable. So here we have plastic toys. Here we have unbreakable. Okay? Then it says the yellow truck is not plastic. Where should I put it? Well, it's not plastic, so it can't go in that small circle. So it could go out here. Or it could go out here. We don't know which. Because we don't know which, that is invalid. Okay, let's take a look at another one. If you saw cats, so let's see, cats, then you like Broadway. Heart, Broadway. If you like Broadway, then you like musicals. Uh-oh. Let's take a look here. We need to add a circle because I have 2 consecutive ifs. So we have like Broadway. Now we can put like musicals. The moment I go to 3 circles and it makes sense, I know right away that is syllogism. Let's take a look at the next one. See if you can do these 2 on your own. Pause the video here. See if you can do these 2 on your own, and then we'll check them. So here's what I got. On the first one, I got plastic toys in the small one, then yellow toys are on the floor, so all plastic toys are on the floor. That makes sense because of syllogism. Here I got if it's cloudy, then there's no stars. Then it says Thomas looks up and doesn't see the stars. So maybe he doesn't see the stars, and whoopsie daisy, I got Thomas in the wrong spot. Let's move Thomas and all his stuff. Thomas, he can't see the stars, but we don't know if that's cloudy or if that's because he's inside, you know, or because he's sleeping, or because whatever. Either way, I'm not sure where to put him, and when I can put him in more than one place, that makes it invalid reasoning. All right, let's take a look at another one. Pause the video here, try this one, and then we'll go over it. All right, you've unpaused. If you listen to country, so there's country, then you have no taste in music. No taste. Michael listens to country. There's Michael. So Michael has no taste in music. So this is detachment. And it's law of. And if you want to abbreviate and put LOD, that's fine. All right, there's some practice. We'll do that next time. That's it for the notes. See you next time, guys.